Edexcel have basically published a cheat sheet on their website, and almost no one reads this thing. It's called the Examiner Report, and it basically consists of all the pitfalls that the examiners from that season saw when marking students' papers. I read 7 of these papers for 9MA0, and what I found is pretty crazy because essentially there are 4 topics that basically always come up, and there are some pitfalls that are consistent throughout all 7 years. If you're sitting paper 1 this year and don't know what they are, this is the video you need to watch. I'm going to walk you through the 4 topics that Edexcel can't stop testing, and I'm going to walk you through the specific traps as well that pop up nearly every single year. And not only that, I'll walk you through the small minor refinements you can deploy today in order to ensure that you don't fall into these things. Quick thing before we get into it: when examiners write these reports, they're not actually writing it for you. They're writing it for teachers. They want teachers to plug the gap. But the side effect of that is that they've accidentally told you, the student, where exactly the last cohort tripped up last summer. And so as a result, what you need to be thinking about is the fact that if thousands of people are making this mistake, okay, and I know we all like to think we're special, but let's be real here. If thousands of people are making this consistent mistake such that it became warranted for the examiner to flag it in a report like this, what makes you think that you're special and won't make this mistake? Because by basis of probability, you probably will make this mistake. So chances are you could easily mess these up as well. That's why it's so important to watch this video. The first topic here is exponential modeling, and this has appeared on basically every single paper I could find, or at least examiner reports of the paper. Now the cover story changes every year, but ultimately the underlying maths does not. So you've got something in the form of v is equal to 8 times e to the power of kt, and you've probably got to find the constants from the 2 given conditions, and then probably differentiate to find a rate, use logs to solve when something hits a particular value. But this is where it gets interesting. Examiners write the same complaint every year. Students get the maths right, but then forget the units. Okay, so this is actually quite similar to the point I raised in the video before, okay, where I spoke about the 8MA0 syllabus specifically. It's all about context. That's what matters here. It's not just about finding a particular point or the gradient. It's about understanding what the gradient means in the context of that question. The reason I'm pulling this out first is basically because, look, it's a pretty easy topic if you just train it, but you don't want to be losing marks for failure to understand the context of the question and not putting the right units down. Okay, so that's very important. Always remember to refer to the context of the question and write the answer with the appropriate units. Now topic 2 is really no surprise, and that is differentiation. And that is specifically questions that include the quotient rule and the product rule. And to make it worse, they usually combine with trig and exponentials to make it even more annoying. From my research, this comes up on every paper 1, without fail. But the strange part of this is the fact that examiners aren't flagging students for not knowing the rule, but they are flagging them for messing up 2 specific micro details. Okay, so picture this. You're 40 minutes into the paper, you hit a quotient rule question with sin x on top and e to the 2x on bottom. You go for it, you quote the formula, you differentiate, and then because you're tired and the clock's ticking, you forget to square the denominator. You didn't notice. And as a result, you don't finish the question properly. But you've just lost 2 marks you'll never see again. Now here's what the reports are telling the teachers in regards to this problem. Reports are telling students to write down the formula before they use it. Okay, so make sure to label u, v, and then du, dx, and dv, dx in a little box at the side. Okay, that's going to allow you then to just plug it in and make things a lot easier for yourself instead of just rushing everything. Because at the end of the day, this is one of those topics where it's so easy to make a silly mistake. Now the other place where students often slip up is rearranging into the required form after they've differentiated. Okay, so the 2018 report was actually explicit about this. It said that students made it harder for themselves by expanding everything instead of factorizing early. The reason I'm going on about this It's basically because differentiation is not that difficult of a subject, but it is very easy to make a mistake during the product and quotient rule. It happens all the time. So what you need to do is basically really, really laser in your focus on those questions, because you know that there's going to be some tricks coming where it's going to be very easy to make some kind of sign error. Now, the third most popular topic is proofs. Here, examiners flag the same mistakes year after year. Students assume that let n equal 2k works for an odd number, when 2k is even by definition. Okay, and for exhaustion, students prove one case, which is usually odd, but then forget about the other. Students will do all the algebra correctly, but then don't write a conclusion sentence, which loses the final mark. But the most common error comes by proof of contradiction. And the reports basically say that students don't know how to set it up. So they write something like, assume n is odd, and then try to prove n is odd, instead of assuming the opposite of what they want to show and deriving a contradiction from it, which is how the proof is supposed to work. And there's actually one recurring error from the 2024 report that's worth flagging specifically. Students kept writing squared numbers are always positive when trying to prove an expression is always positive. But they forget that a squared number can also equal 0. So the proof falls apart the moment x equals 0. And the examiner singled this out as a repeat offender. Now look, I don't think there's an easy fix for this, if I'm being honest. I think the trick is just to get yourself familiar with as many proofs problems as possible and try to understand the core, just the core proof strategies that you need for A-level, right? So contradiction, exhaustion, deduction, counterexample. So once you get more familiar with it, I think things will click into place. But again, you just need to do a lot of volume and just delve into each question if you get it wrong and understand where exactly you went wrong. But of course, the easy fix here is to just ensure continuity in your proofs and logic, and just always have conclusion. Okay, so don't just like leave things hanging. Now, topic 4 was sequences and series. Examiners love this one. So from my research, the marks aren't actually lost on the maths itself. That's typically fine. But the marks are instead lost on 3 other things. So the first is that students confuse arithmetic sequences with geometric sequences and use the wrong setup. That's a pretty easy fix. Just basically look into exactly what each sequence actually does, what its characteristics are, and you should be able to avoid this, right? The other one is that students might get to a value of n, like 15.3, and round it the wrong way. So rounding down to 15 instead of rounding up to 16, because they didn't read whether the question wants the first n that exceeds a value. And then students try adding everything up by hand instead of using the sum formula, which obviously takes forever and always basically introduces a slip in the actual working out. But here was a really interesting curveball that Edexcel introduced in 2022. In 2022, Edexcel asked students to prove the formula for a sum of arithmetic series from scratch. And full marks were rare here because most students hadn't memorized the proof. Now the fix here is actually very simple. You have to just memorize the proof of a sum of arithmetic series and then practice context questions involving compound percentage, growth, decay, until that setup is automatic. Just before we wrap up, there are 3 other pitfalls that don't fall cleanly into these subtopics. So what are those ones? The first one is continuity. So if you're using a sign change to show that there's a root between 2 values, you have to say that the function is continuous on that interval. Every report from 2018 onwards, from what I found, flagged students for skipping this. It is just one word, so that's sorted. The second is that when you define an inverse function, state the domain. So in 2023, the report there literally called it out as a point that has been referenced in many previous examiner reports. So that's funny because even the examiners are getting annoyed at this point. So this is obviously something that they are feeling that kind of pet peeve on. So yeah, do not forget that one. Third are show that questions. So don't skip steps, don't jump to the printed answer. have a clean line of logic that leads to the given result. Okay? Very important. So those 3 things alone, continuity, domain, fully showing you're working, especially in show that questions, that's probably like 5 or 6 marks per paper that you can be leaving on the table for no reason. So look, at the end of the day, the difference between an A and an A star isn't necessarily the maths itself, because you have to understand the maths pretty well to get an A, right? But it really comes down to these like minor nitty-gritty questions. So if you're interested in a full revision system that you can access for free, make sure to click the link below to join the community completely for free, and you can get access to resources to assist you when studying. Link is in the description. Work through the course, ask questions, and that is completely for free.